All right, class. So in the last class, we had started with induction. So only a small topic, that is mutual induction, is left. So induction was what? Basically, induction term means to induce. So induction was what? When the current increased or decreased, so respectively the magnetic flux increased or decreased. And because of this change in magnetic flux that we have been studying from all the laws of EMI, laws of Faraday's law, EMF got induced. You people have your test also today from this lesson. So mutual induction is not there. Don't worry about it, but rest of the questions till here, these are included. Now, current increased, flux got increased, or current decreased, flux got decreased, EMF got induced, which we called as the back EMF, self-induced EMF, or the inducing EMF. All these phenomena occurred in a single coil. In one coil only, current also got induced in that coil. Flux also got changed in that coil. Phi is equal to Li we had seen. E is equal to minus L di over dt, that we have also seen. For the solenoid also we had derived it. Now in case of mutual induction, if you have understood self-induction, then understanding mutual induction is easy. Any doubts from self-induction or last lessons, just ask me. Because or then if you have understood it, then it's very good. Mutual induction is very easy to learn. Now see, just a second. All right. Now mutual induction is what? When induced EMF is generated, induced EMF will here, it will be generated here also. But one more thing that will occur is that the change in current will occur in the neighboring coil. Current will get changed in the neighboring coil. Two coils will be involved over here, not a single coil. In self-induction, what happened? There was a single coil, current changed here, flux changed here, EMF got induced over here. In this coil only, all the phenomena occurred. In case of mutual induction, for example, if I tell you, let's take a coil. This is one coil with a normal battery and a key system. All right. So battery is there, a key is there. This is the coil. Now, in order to modify or change the coil, let's connect a rheostat. Rheostat is basically a device to change the resistance. And as you change the resistance, your current also gets changed. Then there is another coil that we'll keep in proximity to this coil. And we'll connect a galvanometer. Now, I have written P over this coil and S over this coil. This you will study in AC as well. P is the primary coil. S is the secondary coil. So change in current and flux and everything occurs in the primary coil. And that effect is shown in the secondary coil. This is one experiment that you can study. So what happened? Two coils are there, PS, which are placed close to each other. The coil P is connected to the series battery and the rheostat through this tapping key system. Now, this coil, S coil is connected to a galvanometer so that it can detect the flow of current as when the current flows. So when the current flows through coil P, it produces a magnetic field which produces a magnetic flux through this coil. Now what happens if the current in the coil P is varied? The magnetic flux linked with this coil S will also change. And how do we know whether it is changing or not? By the deflection seen through the galvanometer. Either it will move in this manner or in this manner. So we call this as the primary coil. because it causes the induced EMF, and second one is the secondary secondary coil, because it is in this coil where the induced EMF has been induced. And this phenomena, this total entire phenomena, is known as mutual induction. In simple terms, no. See, in simple terms, you can remember it like this. This occurred in coil 1, this phenomena occurred in coil 2. And that's why we had induced EMF. Simple. Let me tell you the definition also. So mutual induction is what? It is the phenomena of production of induced EMF in one coil. Due to what? Due to change of current in the neighboring coil. This phenomena is mutual induction. Now, rest of the things are very easy. The rest of the things are just exact replica of what you have studied in the last class. We didn't have the class on Monday, no, because of Independence Day. So I think the last class was also on Wednesday. So 1 week we have it. Fine. So here also you will see flux is directly proportional to the current. So here, this is the magnetic flux, that is, this is what? This is the magnetic flux linked with the primary coil. And this is the current. No, this occurs in the secondary coil. No, current changes in the primary. Linked with the secondary coil. And this is the current in the primary coil. This is the current. So here also we'll be putting a constant and an equal to sign to form an equation. So here, class, what will happen? Instead of L that we had, that was self-inductance, we'll be having mutual inductance. So here M is what? M is the coefficient of mutual inductance, or you can say this is mutual inductance. Or this is mutual inductance. Coefficient of mutual induction. So rest of the things remain the same. If you have to define one mutual inductance, 1 M, how to define 1 M? 1 M will be equal to 1 Weber, that is flowing for 1 ampere of current. Fine, this way you will write it. Now phi is equal to MI. Not electric field, sorry, EMF. EMF is what? EMF is minus d phi over dt. This is from your Faraday's law, that EMF induced. That's what we have been studying in this entire lesson. That EMF is induced, which is the rate of change of magnetic flux, whose direction is given by Lenz's law. So if you place minus dmi over dt, again you will get the same formula. It's just that here the coefficient has changed. Minus di over dt. This is the formula for it. And SI unit is also the same. SI unit is 1 Henry. How to define 1 Henry? Similarly, 1 volt means mutual inductance of two coil is said to be 1 Henry when induced EMF of 1 volt is set up in one coil, when the current changes in the other coil at the rate of 1 ampere per second. This is mutual inductance. Similarly, we'll be having a case of mutual inductance of long solenoids. But before that, just write down these things. Then we'll do the formula of solenoid. We'll do questions on this. We'll then start with AC, alternating current. I think test papers have shown, I have sent you the marks, no? Did you people receive it? Last test which we had.
Yes,
Derivations, no? Yes.
only the marks, not the papers, brother.
Yes, marks, no? If you wish, I'll show you your papers as well. That if there is any confusion. I think Zaid and Khalid have scored full marks. So, Zaid has scored 15 on 15. Zaid's paper was very nice. Everything was written perfectly. Khalid also, Samaira, what were the mistakes? Yes, Samaira. At the last, see, only one score has been lost in this question. See, Samaira, you have to tell what are you writing. This step you have to mention why did you write 2 pi r. You have to show it that this is the integration of dl, the way you had shown it for by, but by eventually came out to be 0. So you have to show that this is integration of bx, so that you are writing mu naught I by 2 pi r into integration of dl. Then tell integration of dl will be 2 pi r. Then write these steps. Fine. Otherwise, just writing down this may lose your marks in the board exam. It can happen. You can get full score also in this question, but it can also happen that marks are lost. Fine. And just specify. See, one thing that you have missed over here is R. You've got confused between R and X. Fine. And your final answer is not getting correct. That's why you're losing your marks. Just check the main formula. What is the formula for? Just revise the end portion. Initial starting was done correctly. And Samaira, major marks have been lost in this. See, this was dielectric slab introduced, which was partially filled. Did I in the paper mention it? That it is partially filled. I just wrote dielectric constant K is there. So this derivation you had to do. If this the derivation of which you have written, that is fine, that is perfect, but the question is incorrect for that. All right, and last question was correct. Fine, I think Salman is no, Hania is traveling today. No, she is present. Salman, what is the mistake? First question, right? Second question is also right. Yes, your this last answer, horrible answer, Salman. Everything was perfect. I don't know what happened at the last. You've also written your pen ran out of ink. That I understand, but your answer should be correct. No, at the end, I don't know what did you write. But here, some of the things were missing, sigma and all those. The way you have done the first and second question, just do it in that way. Rest of it, your paper was fine. If I think 5 more minutes were given, you might have done this correctly. The rest of it is fine. And Maimuna, she's joining from September. All right. So any doubts in the paper, ask me. You have your test today as well, no? C class, mutual inductance of two long solenoids. So in your exam, you can get a question, derive an expression for the mutual inductance of two long coaxial solenoids on factors they depend and all this. Now see, what did we do? We have considered two coils. So this is first coil, this is the second coil. Now in these coils, see what is happening. Let's specify certain term. Let's say for this coil, R1 is the radius of coil 1, R2 is the radius of coil 2. I1, this is the current in coil 1, I2 is the current in coil 2. Now length is same, length of both the coils is L, L is the length of the coils. Any other term left? Yes, N1, number of turns in first coil. N2, number of turns in coil 2. Fine. Now see what will happen. See, as the current will change in one coil, EMF will be induced in the second coil. So let's say when we first pass a time varying current I2 through this. So what happens? What is the magnetic field that will be set? Tell me one thing. Do you people remember in self-induction also we did? What was the formula of magnetic field of a long solenoid? In self-induction also we did it.
And that
Yeah.
mu naught Ni?
Mu naught Ni. Yes, that's right. Mu naught Ni. Where N is what? N is number of turns per unit length. So here also, what will happen if current is changing in second coil? Let's say the current is changing in the second coil. So magnetic field that will be set up in the second coil will be mu naught N2I2, because the formula of magnetic field is equal to mu naught Ni. So for the second one, everything will be 2 to 2. And also N2 is not number of turns, simply it is number of turns per unit length. Do keep this in mind. Now the flux that is changed in the first one, which magnetic field is responsible for this flux change? The first one or second one? Anyone has an idea? I have told you it actually. Flux that is, yes, second one, right. Salman has answered, I think, no? Yes, right. Second one. See, magnetic flux, current, everything got changed in the second one. That's why we are able to observe the flux change in the first one. So remember, flux is what? BA cos theta BA. And if n number of turns are there, then it becomes NBA. So what will phi1 become? N1. Area will also be A1, but what about B? B will be B2 this time. So phi1 is equal to N1 A1 B. B2 A N1. Even if you put the values of B, so this becomes N1 A1 mu naught N2 I2. Even if you wish to put, you can put it. Now, what is mutual inductance in the first coil with respect to the second coil? This will be phi was equal to Mi. So M will be equal to phi divided by I. Now, which phi, which I? See, we are calculating the mutual inductance of coil 1. Induction has occurred in which coil? Coil 1. But because of change in current in which coil? Second one. That's why phi1 divided by I2. This is what? This is mutual inductance of coil 1 with respect to coil 2. Here, mutual inductance of coil 1 with respect to coil 2. Phi 1 divided by I2. Why phi 1? Because mutual inductance is occurring in this coil, first coil. But due to which coil? Second one. That's why I2. So now we just have to put in the values. This will be mu naught N2 A into N1 from here, because I2 will get cancelled. So only this much will be left. Or even if you want to write it in terms, N2 also in terms of N1. So N2 was what? N2 was N2 divided by L. So this becomes mu naught N1 N2 area, and in the denominator you have L. This is the formula for it. Similarly, if you want to find out mutual inductance of second coil with respect to first one, M21, then that will be phi 2 divided by I1. Same derivation you will perform. At the end you will get mu naught N1 N2 A divided by L, if this will be the same. So you can even say M21 is equal to M12 actually. You can say it as M. Now, if you want to write, you can further modify this formula also. Main formula is this only. Mu naught N1 N2 area divided by the length. You can modify it. You can write this, you can multiply and divide it by L. So this becomes mu naught N1 N2 area into L. Or you can even write the area, whichever coil is asked, N1, N2, pi R1 square, pi R2 square, whatever is required. So this also you can use. So this becomes the formula of the mutual inductance of the two coils. And one more thing. Coefficient of coupling is also a very short thing that comes. It can come coefficient of coupling. This is basically a relationship between mutual inductance and the self-inductances of both the coils. See, if two coils are there, let's say these are two coils, current has increased in this, flux has increased in this. But see, if current has increased in this coil, it can happen that flux is also changed within this coil and EMF is induced. So it will having a self-inductance. Similarly, this coil will also be having a self-inductance within itself. But since both these coils are kept together, both of these will be having mutual inductance as well. So relation between them is given by this, which is known as coefficient of coupling. This comes in the question as a 1 marker, only as a 1 marker. For students who are preparing for entrances, for you this formula becomes important. For class 12 board, only for 1 marker, it can come. It can happen that it can be asked what is the coefficient of coupling. Just writing this much is sufficient. You just have to write M is mutual inductance, L1, L2 are the self-inductance. So let's do some questions. But before the questions, no, just write down these things. First, tell me clear mutual inductance, self-inductance, and this whole topic, because from your lesson EMI, no. See, only 3 types of question come from EMI, apart from derivations and formula thing. First type of question comes directly from E is equal to minus d phi over dt. Second type of question comes from motional EMF, E is equal to BLV. And third type of question comes from your inductance. Then the derivation and law statement things can come. So EMI is a short chapter. Please keep on revising it even after today's test. Only Zaid has submitted his answer. Yes, Zaid, that's correct. Right answer. Let's discuss it now. I think sufficient time was given. Length is what? Length is given to you as 50 centimeters. So that becomes 0.5 meters. Now, number of turns in the first one, this will be number of turns multiplied, number of turns per unit length multiplied by the length. So number of turns is 20 turns per centimeter and length is 50 centimeter. So I'm not converting here centimeter because this centimeter will cancel with this centimeter. So this will be 1000. Similarly, N2 will be what? N2 will be N2 into N. This is given as 25. So 25 into 50 is what? 1250, no? Now we have to write down the area. We have to determine the area of the cross section of the inner solenoid, because obviously if this is the larger solenoid and this is the smaller solenoid, so see, induction EMF, every phenomena will occur only in this region because this is the common region for both of these. Fine. See here, this portion, this is the common region for both of these. So that's why we'll be having here only. A2 will be considered pi R2 squared. So pi, what is R2? What's the radius given? Okay, area is given 25 centimeters. No need to calculate. This is given as 25 centimeters square. So we'll convert this 25 into 10 to the power minus 4 meters square. Now M is what? Mu naught I1, not I1, N1, N2. Naught N1, N2A divided by L. This becomes 4 pi into 10 to the power minus 7. N1 is 10 to the power 3. N2 is 1250. A2 is 25 into 10 to the power minus 4 divided by length was 0.5. So as rightly answered by Z, this will be 7.85 into 10 to the power minus 3 Henry, which is equal to 7.85 millihenry also you can write it. 7.85 millihenry. All right, note it down. Written.
Yes.
So that completes EMI. Let's do certain portions of AC. At least just have an introductory class of AC. AC dynamo, at least we can complete. Then we will have the test of EMI. Now see, alternating current. This is basically your chapter number 7 from NCERT. All right. Now first the term alternating current. Why alternating current has been provided? What is the difference in this current right now? See, alternating current is a different current. You can identify it from the term only alternating. But before that, regarding the previous current that you have been using up till now, that current was known as direct current. The short form is DC. We always use this term DC. Direct current. Now, in till your all the lessons that you have studied, all your current electricity circuits, what all circuits that you have studied, those are what? Those are basically what? Those are the direct current. Reason is that direct current is that type of current that does not change with respect to time. For example, if I talk to you about the circuit current, if there was a resistor, a battery was there, what happened when we connected with the resistor with the help of wires to the battery? In that specific circuit, if I talk to you about this specific circuit, this is a battery. Let's say this is 10 ohm resistor and 10-volt battery is there. So I say 1 ampere of current is flowing. So am I saying that at this point the current is 1 ampere, at this point current is changing, at this point current is 0.5 amperes, here the current is no. If I am saying current in this circuit is 1 ampere, it means in this entire circuit it will remain 1 ampere only at any point if you consider. So it means as the time is passing, then there is no change in current. If value is remaining fixed, don't get it confused in this way. That you studied now, branching. Remember when we did series and parallel combinations of resistors, capacitors, there we had seen when branching occurs, then in case of capacitor, charge divides, and then in case of resistors, current divides. See here, that is a different thing. If a branching is occurring, if a branching has occurred, current gets divided, so different types of current come. But in each wire, what is happening? In each wire, every wire has its own value of current that remains throughout the entire wire. It's not like if I talk about this wire, if I am saying 5 amperes is flowing through this wire, then if 5 amperes is flowing at this point, 5 amperes will flow at this point, 5 amperes will flow at this point. Value of current is not changing. That was the direct current, which you have studied till now. So even if you plot a graph of direct current, even if you plot a direct current, so this is your current, this is versus time. So at a certain time, current will have this value. So what will happen? At this point of time, current has this value. Let's say this is some value. Now, as the time will increase, its value will increase. As the time will increase, but the value of current is remaining the same. Value of time is increasing. Current is still the same. Then we'll increase the time further. We'll see the current is having that value only. For t is equal to 5 seconds, current is 5 amperes. For t is equal to 10 seconds, current is 5 amperes. So that is your direct current. And one of the important things is that source. From where do we obtain this direct current? Normal cell or battery. Wherever you have cell or battery, you will be obtaining direct current. Then you have what we were studying. Alternating current. Alternating current. Now, alternating means alternating with what? Alternating with time. As the time is passing, values of current will be different. That we do not see normal, all these resistors where light is coming and all those resistors and devices. No. We have specifically AC generators that we'll study today only. We'll try to cover it. So alternating current is what? With passage of time, no. For example, this is your current versus time graph. This will be the variation. Means if you see at this time, this is the max, this is the value of current. At this time, this is the maximum value of current. At this time, this is the maximum value of current. Again, at this time, this is the maximum value of current. Similarly, for all different values of time, time is varying. And what do we say? What's the source of it? Source is basically AC dynamo, or we call it AC generator as well. Now all the previous concept of EMI will come that you have studied. Just note down till here. Then we'll start with AC. Then. Now AC generator or dynamo. This is the concept is just similar to EMI. So AC generator or dynamo. See, AC generator is basically what? You have to understand just one thing. Mechanical energy, you people are aware of. Mechanical energy is the normal energy that you've studied, the kinetic energy plus the potential energy. So energy that comes with respect to change in position, change in motion due to interaction, that sum of all those energy, that is known as the mechanical energy. So this is a device that converts what? Mechanical energy into electrical energy. Electrical energy, that's why we have AC current. Electricity is passing. So mechanical energy into electrical energy. So mechanical energy into electrical energy. Fine. This is a what is meant by AC dynamo. Now, in the question, principle will be asked. Principle is the chapter which you have studied. In the last class, not the last class. Today only we have completed that lesson. Electromagnetic induction. What is the law? What are the laws of electromagnetic induction? We have been studying only one thing, and we were just adding points here and there. But the basic concept till induction remained the same when we were discussing electromagnetic induction. In case of electromagnetic induction, what was it? EMF got induced. EMF got induced because of what? EMF got induced because of rate of change of flux. That was the whole concept of EMI. So principle is the same. Principle, it is based on Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. So, which is what? Whenever magnetic flux linked with a coil changes, EMF is induced. It is exactly based on this. But what's the difference? How will the magnetic flux be changed? Whichever magnetic flux is linked with the coil, how will it be changed? So just one thing that you have to remember, in this case, in case of AC dynamo, the magnetic flux gets changed because of the rotation of the coil when it is kept in uniform magnetic field. So just remember this point: in an AC dynamo, magnetic flux gets changed due to rotation of coil in uniform magnetic field. Fine. In an AC dynamo, magnetic flux gets changed due to rotation of coil in uniform magnetic field. Means coil is there. Perpendicular to the coil is area vector. Magnetic field is there. But as the coil will change, the angle between area vector and magnetic field will also change. So if the angle between area vector and magnetic field is changing, so what will happen? You will get different values of EMF, different values of flux. Then it changes further at any angle if it is there. So there will be different angles for it. See, basically, what happened? Just see the construction, then you'll be able to get it. Two magnets are there, north pole, south pole. So magnetic field lines will be there. In between a rectangular or any shaped coil, mainly rectangular coil is kept like this. And the edges are held with the help of slippery rings. And these slippery rings are connected to brushes. This is the slippery ring. This is the brush. Like the slippery rings and the brushes are there. Even to make the conductivity occur, a resistance is connected. We call this resistance as load. No need to go into the details of this. Just say two magnets are there and the normal armature is here. Fine. Now we have a portion of theory, but I think first note down till the construction, then you should write down the theory. Theory is easy. Theory is easy, but I think write down these points first. These are short points. Then we'll do the derivation part. A very small portion is left and it's easy. Just note it down first. These certain terms I'm specifying. N is what? N is the number of turns in coil. A is the area of coil. B is the magnetic field. These terms you are aware of. Now, additional term that will come is omega. See, coil is not moving like this. In case of BLV, motional EMF, the coil moved. So we had to take the velocity, linear velocity. Here the coil is rotating. So there will be certain displacement. So there will be certain velocity. So there will be an angular velocity. So omega is what? Omega is the angular velocity. Does anyone remember the formula of angular velocity? You have done this in class 11th in your rotational dynamics. Omega. What is the formula for it? Nobody remembers. Omega is theta by t. Displacement divided by time is velocity. So angular displacement divided by time is angular velocity. From here, theta can be written as omega t. And remember, throughout AC, this cos omega t, sin omega t, these terms will come. That obviously we will not do today. That those terms we'll discuss it in the next class. Yes, they have come. This is BA cos omega t. BA cos theta, you know. So BA cos omega t it becomes. Similarly, if you write minus d phi over dt for EMF, this becomes minus d over dt of BA cos omega t. Now, BA, both these terms are constant. Minus BA, this is constant. But differentiation of minus cos omega t. What is left over here? Differentiation of cos omega t. Remember, this will be used a lot. Minus BA cos omega t. Omega is a constant in terms of differentiation or integration whenever you have trigonometric function. For trigonometric function, these constant terms which are in the angle, which are present in the angle, these come out and get multiplied, and then what is left? Not cos theta, we'll be writing minus sin theta. So differentiation, this gives minus sin theta. So minus omega sin omega t. This is the differentiation of cos theta. So EMF becomes BA omega sin omega t. And in this, see, maximum value of EMF that is possible. If your sin omega t, this term, if sin omega t is plus 1, then maximum value of EMF which is possible, it will be BA omega. For that, sin omega t has to be plus 1. And you know when sin theta is 1. Even the graph, no, graph of EMF versus time, this varies like this. This is all the students who are having maths. You people already know the graph of the sine graph. If it is a cos graph, it starts from here. That we'll see. All these things we'll see in the next class. This is what? This is the maximum value of EMF, Emax. And this one complete period for the one wave to complete its motion, this is known as the time period. So no need to go into these details. Just understand that the graph will look like this. This is the amplitude. This is the maximum value. This is the origin of the graph. And the graph is varying sinusoidally. This is known as sinusoidal variation. This is known as sinusoidal variation. Fine, rest of the things you will be able to understand in the next class, but more or less this was about AC dynamo. We'll study more in detail, EMF and everything. Don't worry about it. First, note it till here. When you are done, text me done. Then after 5 minutes, I'll start with the test. Test is easy. Two numericals are there. Two theory questions are there. after 2 to 3 minutes, I'll start with the test. So all those who have written, just take a break of 2 to 3 minutes. Yes, class, please start with the test. Salman, send it on the group only, because when I start checking the papers, every paper get mixed up if it is sent on personal. So it's better if you send it on the group. I'll have all the papers together. Fine.
Yeah, okay, ma'am.
Okay, Salman. Thank you. Yes, Zaid and Samaira, wind up now. Last 4-5 minutes are left. All right, Samaira, you can leave. I've received your paper.